This video will be covering the basics of analysis of variance and F-testing. Analysis of variance, also known as ANOVA, decomposes the total variation into that which is explained by group membership and that which is not. And F-testing can determine, does sample or group membership matter? Are there differences between these groups? And does group membership explain a significant amount of variation in some variable? So for analysis of variance, our goal is to explain how much variation in Y is explained by some kind of group membership. So if we have some variation in Y that is explained by group membership, we have between group variation. Maybe we have some variation in Y that is not explained by group membership, and we have within group variation. So to make more sense of this with an example, you have some data on some wages for a random sample of American residents. How much of the variation in these wages can be explained by race, and how much is not? The variation in the data explained by race would be between group variation, and the variation in that data not explained by group membership in a racial group would be within group variation. Or maybe you have data on students at a high school, and you have their test scores. How much of the variation in these test scores is explained by a student's teacher? So group membership in a group, a class groups. So between group variation would be the variation in test scores by students that have different teachers. And within group variation is going to be the variation in test scores between students who are in the same class with the same teacher. So, to compute an ANOVA, we're going to decompose the overall variation into within group and between group variation. Within group variation is going to be variation relative to the group's mean, and between group variation is the variation between a group's mean and the overall mean. So when we talk about decomposing the variance, what we're doing is taking the total sum of squared deviations given by this formula. We're getting the within sum of squares, or within group sum of squares. And we're going to take the between group sum of squares. The sum of squares total is equal to the sum of squares within and the sum of squares between by construction. So the sum of squares within divided by the total sum of squares is going to give us the percentage of variation that is within group, and the sum of squares between divided by the sum of squares total is going to give us the percentage of variation that occurs between the groups. Next, we're going to compute an example in the Excel video. And this data comes from 41 individuals who primarily use one of these three drugs, crack, meth, or marijuana. And what we're looking for is to determine if the ages of drug users differ by the primary drug of choice. And we'll be looking at this in the next video in the Excel example. But for now, we're going to talk about the F-test. So another way to say this is group membership statistically significant? Or is the between sum of squares statistically different from 0? And some examples of when variance decomposition might be informative could be some really current and pressing issues in policing, such as, does the incidence of traffic stops vary by race? Does having a certain teacher or teacher quality affect students' educational outcome? Does an infant's birth weight vary by mother? Is a statistical model useful? So in F-testing, we want to know if group membership matters with respect to determining some variable, Y. And another way to ask this question might be, are the group means equal to one another? If all the group means are equal, then there is no between group variation. All the variation would be within group. To answer this question, we're going to conduct a hypothesis test similar to all the other ones that we've gone over so far. So, we're going to reject our null hypothesis, meaning all group means are equal, if the between sum of squares is sufficiently large relative to the total variation. Our test statistic f will quantify the amount of evidence against our null hypothesis. If the test statistic f is greater than our critical value, f critical, we will reject our null hypothesis. Group membership appears to matter. The formula for the f-test statistic is just as follows. The sum of squares between over the degrees of freedom between, divided by the sum of squares within over the degrees of freedom within. And the f table, very similar to the t and the z tables that we've used so far, is given right here as an example, and this is where we'll find our critical value and make our determinations about our hypothesis. In the following video, we'll explore f-tests and ANOVA in Excel and R.